So in this lecture, we want to discuss sample size calculation. We didn't discuss it in the other lectures, but we need to discuss so that you understand how to calculate sample size. Most of your studies which you are going to do, they are going to be descriptive studies, and for these descriptive studies, um, these are cross-sectional descriptive studies, which most of you will do. And for these descriptive studies, which are cross-sectional, we use what we call the Dobson formula for calculation of sample size. So I will discuss how to calculate the sample size using the Dobson formula, and I'll also give a few examples so that you can understand the whole process of using this Dobson formula. So this is the Dobson formula which you use to calculate sample size, where you've got your z squared, your z squared, p1 minus p times 1 minus p over d squared. So in terms of the meaning of these parameters in this formula, z is the standard normal variate. So I'll not really go in detail in terms of really trying to to explain whatever the meaning of these things. These are more of statistical things which are beyond your level. So z is the standard normal variate, and if you are using a p value of less than 0.05, the z will have a standard value of 1.96. So for most of the studies, our z will be 1.96, since we'll be using p value of less than 0.05. Then p is the expected proportion in the population, based on previous studies or pilot. In most of these studies which we'll be doing, cross-sectional studies or descriptive studies, we do these studies in a population, and in this population there are other studies which have been done, maybe looking into the same issue. So we use those studies to come up with a p, which is the proportion, what we really expect to find. This will be a p. Then your d, that's the precision or the error. So in most of the studies, usually we use an error of 5%. So let's use this example. Let's use this example to try to explain how do you use this Dobson formula. For example, let's assume that a researcher wants to estimate the proportion of patients having hypertension in the pediatric age group in a city. According to previous studies, the actual number of hypertensives may not be more than 15%. The researcher wants to calculate the sample size with the precision of 5%, with the precision of 5%, and type 1 error of 5%. So if you use the above formula now, remember we said when you are doing studies, you do these studies in a setting where some studies have been, you have something which you're expecting. So in this one, they expect, the number of people with hypertension to be 15%. So our P in this formula becomes 15%. Then 1 minus P, that's 0.85. Then our Z is the standard, so it's 1.96 squared. Then our precision our precision is 0.005. So if you use these parameters from this, you will get a sample size of 196. So for this cross-sectional studies, the researcher has to take at least 196 subjects. So if the researcher wants to increase the error or decrease the precision, so this is the precision, the denominator, so yeah, you can actually change the size of the sample size by, if you change any of these parameters, but you can't. Z is standard. The precision, you can change it. whatever value. But as I said, I'll not go in detail. So I'll also give other examples to try to really, because most of our studies which we do, I think we have got two, if you look in terms of our main, I used this example to try to illustrate so that you understand how do you use this Dobson formula. This is an example. Most of our studies usually we are looking into factors, associated with various outcomes. So I'll use the factors example as an example to illustrate how do you find out the p for such studies, which is the proportion. So example one, remember I've got two examples. They are looking, the topic is the same, but actually we are looking at different, the topics are the same, but the outcomes in these studies are different. So the first one, in the example one, factors associated with work-related stress. If you want to estimate the sample size of such a study, you use proportion from a study which assessed the associated associated variables. So remember, you look for other studies which have looked into factors. These factors now they become your variables, which are associated with work-related stress. Remember, if you look into these studies, which looks into factors, whatever challenges, or some of these variables which are linked to a certain outcome, there might be a lot of factors which people might study in those studies. But for you now, when you want to look for the proportion for your sample size calculation, you look for a variable which is key in your study. Like in this case, this study is looking into factors associated with work-related stress. Maybe in this study, one of the variables which might be key in terms of really determining stress is career development. So maybe in this, you read literature, and you find a study where 80% of employees wouldn't they have career development and stress. You can then actually use a P of 0.81. So I think just to sum it up for in this example, when you are doing studies which are looking into factors and there's variables which are linked to a certain outcome, you then choose a variable which do you think which for your study maybe will be the important or the key variables. You can then look into literature, look for studies where that primary variable has been assessed, and you use that the proportion from those studies to calculate your sample size. Then if you look in the next example now, this is different. This one, we're not looking into the factors associated with work-related stress, but we want to estimate the prevalence of work-related stress. So these two things are different. All of them, they are cross-sectional, studies. The other one, we are looking into factors associated, but in this one now, we want to estimate the prevalence of work-related stress. So in this case, it's the same example like the one like this one. Is the same example with the one which I gave you, where we are looking in the hypertension. So in this case, you use the proportion from a study which assesses the prevalence of work-related setting in a similar setting. And it is, so let's assume there was a study which was done maybe in this setting to assess the prevalence of work-related stress, and they find it to be 60%. So you then use this 60% as as your P, and it for in your sample size calculation. I hope you see the difference between these two. This one, we are looking into variables associated with an outcome. Then in the other one, we want to estimate, that outcome. So if you are using variables, you choose the key variables among your variable, which you can then use for calculation of your sample size. But when you are estimating that outcome, actually, it's different now. You look for a study which also estimated which estimated that outcome in a similar setting. Maybe it might not be for example, we're in Zimbabwe. the study might not have happened. You might look for literature and you might not found a study which was done in Zimbabwe. You can look a study which was done in similar setting, in this case in Africa or maybe in neighboring countries. The same applies for also factors which are related to stress. So I also give another example in terms of how then do you write this how then do you write this thing when you're writing your proposal. This is an example of a study which we did in Zimbabwe, where we wanted to evaluate the transport management system. So in this case, we found a study which was also done in Zimbabwe, which looked into the transport management of the expanded support district program. I think this is an HIV program. In this study, they found that 86% of the drivers were able to state information that should be filled in logbook. Among our variables or our factors were this variable where I wanted to assess if drivers were able to really complete the logbook. So we chose that as our key variables, which we thought it was critical. So using the proportion, we then use this from this study, which we found of 86%, using the proportion of 0.86 formula and the Doson formula, the minimum sample size of drivers required for this study will be. So first, you write your assumption. What is your P? Your P, and these are the assumptions which you are going to be using to calculate your sample size. So your P is the proportion of drivers able to state to fill the logbook, which is 0.86. Then you have got your standard, your Z, which is at 0.05 at 5% risk. That's 1.96. Your precision, that's 0.05. And if you're using your Doson formula, which is Z over your precision, which is delta squared P 1 minus P. If you plug in these things in the formula, you get 185. So that's the sample size of drivers which we wanted for that study. Usually, when we are doing researches, we don't expect everyone to respond. Some of the, we don't expect the 100% response rate in most of the research. Some of the study participants might actually refuse. So usually, we then try to to cater for that non-response. So in this case, assuming 10% of the drivers will not respond, we can then say 185 and of our sample times 10%, we get 19. We then add this 19 plus 185 to get 240 to get 204. So in this case, our minimum sample becomes 204 for drivers, where we are now adding this non-response. Remember, we are talking of the minimum sample size. Remember, the minimum sample size. So by the minimum sample size, what are we saying? We are saying that's the minimum number of study participants which we need to find whatever we want to find or whatever associations we are looking for. But we can actually go more than the minimum sample size. But in most cases, you don't need to go over the minimum sample size. Otherwise, if you then recruit a lot of these if you recruit a lot of more than your minimum sample size, you end up having problems. So otherwise, I think this is the end of this lecture. In terms of really how do you calculate your sample size. So just to recap, in terms of your sample size calculation, as I explained, with our what we are doing, most of our studies which we are going to be doing, these are cross-sectional studies. You then use a P. It depends. If you want to estimate an outcome, you use a P from studies which have been done. If you are looking into factors, You choose one of the factors which is key, which you then use for your sample size calculation. So this is the end of the lecture. We will share the notes with you so that we can follow up on these issues.